Sweet corn is a variety of maize with a high sugar content. Sweet corn is the result of a naturally occurring recessive mutation in the genes which control conversion of sugar to starch inside the endosperm of the corn kernel. Unlike field corn varieties, which are harvested when the kernels are dry and mature, sweet corn is picked when immature and prepared and eaten as a vegetable, rather than a grain. Since the process of maturation involves converting sugar to starch, sweet corn stores poorly and must be eaten fresh, canned, or frozen, before the kernels become tough and starchy. History: sweet corn occurs as a spontaneous mutation in field corn and was grown by several Native American tribes. The Iroquois gave the first recorded sweet corn to European settlers in 1779. It soon became a popular food in southern and central regions of the United States. Open-pollinated varieties of white sweet corn started to become widely available in the United States in the 19th century. Two of the most enduring varieties, still available today, are Country Gentleman and Stahl's Evergreen. Sweet corn production in the 20th century was influenced by the following key developments: hybridization allowed for more uniform maturity, improved quality and disease resistance. In 1933 Golden Cross Bantam was released. It is significant for being the first successful single-cross hybrid and the first specifically developed for disease resistance. Identification of the separate gene mutations responsible for sweetness in corn and the ability to breed varieties based on these characteristics, Su, Se, Shtu. There are currently hundreds of varieties, with more constantly being developed. Anatomy: the fruit of the sweet corn plant is the corn kernel, a type of fruit called a chiopsis. The ear is a collection of kernels on the cob. Because corn is a monocot, there is always an even number of rows of kernels. The ear is covered by tightly wrapped leaves called the husk. Silk is the name for the pistillate flowers, which emerge from the husk. The husk and silk are removed by hand, before boiling but not before roasting, in a process called husking or shucking. Consumption: in most of Latin America, sweet corn is traditionally eaten with beans. Each plant is deficient in an essential amino acid that happens to be abundant in the other, so together sweet corn and beans form a balanced diet. In Brazil, sweet corn cut off from the cobs is generally eaten with peas. Similarly, sweet corn in Indonesia is traditionally ground or soaked with milk, which makes available the B vitamin niacin in the corn, the absence of which would otherwise lead to pellagra. In Brazil, a combination of ground sweet corn and milk is also the basis of various well-known dishes, such as pamonha and the pudding-like dessert curau, while sweet corn eaten directly off the cobs tends to be served with butter. The kernels are boiled or steamed. In Europe, China, Korea, Japan and India, they are often used as a pizza topping, or in salads. Corn on the cob is a sweet corn cob that has been boiled, steamed, or grilled whole. The kernels are then eaten directly off the cob or cut off. Creamed corn is sweet corn served in a milk or cream sauce. Sweet corn can also be eaten as baby corn. If left to dry on the plant, kernels may be taken off the cob and cooked in oil where, unlike popcorn, they expand to about double the original kernel size and are often called corn nuts. A soup may also be made from the plant, called sweet corn soup. Health benefits: cooked sweet corn increases levels of ferulic acid, which provides anti-cancer properties. Varieties: open-pollinated corn has largely been replaced in the commercial market by sweeter, earlier hybrids, which also have the advantage of maintaining their sweet flavor longer. Su varieties are best when cooked within 30 minutes of harvest. Despite their short storage life, many open-pollinated varieties such as Golden Bantam remain popular for home gardeners and specialty markets, or are marketed as heirloom seeds. Although less sweet, they are often described as more tender and flavorful than hybrid varieties. Genetics: early varieties, including those used by Native Americans, were the result of the mutant Su allele. They contain about 5–10% sugar by weight. Supersweet corn are varieties of sweet corn which produce higher than normal levels of sugar developed by University of Illinois at Urbana-Champaign professor John Laughnan. He was investigating two specific genes in sweet corn, one of which, the SH2 gene, caused the corn to shrivel when dry. After further investigation, Lafnan discovered that the endosperm of SH2 sweet corn kernels store less starch and from 4 to 10 times more sugar than normal SU sweet corn. He published his findings in 1953, disclosing the advantages of growing supersweet sweet corn, but many corn breeders lacked enthusiasm for the new supersweet corn. Illinois Foundation Seeds Incorporated was the first seed company to release a supersweet corn, and it was called ILN Extra Sweet, but widespread use of supersweet hybrids did not occur until the early 1980s. The popularity of supersweet corn rose due to its long shelf life and large sugar content when compared to conventional sweet corn. This has allowed the long-distance shipping of sweet corn and has enabled manufacturers to can sweet corn without adding extra sugar or salt. The third gene mutation to be discovered is the SAY or sugary enhanced allele, responsible for so-called everlasting heritage varieties, such as candy corn. Varieties with the SAY alleles have a longer storage life and contain 12–20% sugar compared to SU varieties. All of the alleles responsible for sweet corn are recessive, so it must be isolated from any field corn varieties that release pollen at the same time. The endosperm develops from genes from both parents, and heterozygous kernels will be tough and starchy. The SAY and SU alleles do not need to be isolated from each other. However, supersweet varieties containing the SH2 allele must be grown in isolation from other varieties to avoid cross-pollination and resulting starchiness either in space or in time. Modern breeding methods have also introduced varieties incorporating multiple gene types. SY adds the SH2 gene to some kernels on the same cob as a SAY base. Augmented SH2 adds the SAY and SU gene to a SH2 parent. Often seed producers of the SY and augmented SH2 types will use brand names or trademarks to distinguish these varieties instead of mentioning the genetics behind them. Generally, these brands or trademarks will offer a choice of white, B-color and yellow varieties which otherwise have very similar characteristics. BT corn. BT corn is genetically modified to resist certain insects. Commercial growers have access to sweet corn seed bred with this artificial trait. BT corn and other transgenic varieties are not available to the home grower due to protocols that must be followed in their production. See also, list of sweet corn varieties, cornbread, cornmeal, creamed corn, frozen vegetables, corn syrup, references.